Okay, so here's a little lesson on fractions. One of the things that we're going to work on first is how do we simplify a fraction? And it's different depending on what the fraction looks like. If the big number is on top and the small number is on the bottom, then we need to think division. The top number divided by the bottom number. So in this case, it would be 35 divided by 6. Or if you're going to put that in your calculator, it's the top number divided by the bottom number, because fractions are division. And so how it works is, like, we would say, okay, 6 into 35 goes 5 times. Multiply the two numbers there. 5 times 6 is 30, and you write it down here. And then you subtract it. And what we have left is 5. And what happens is, you know, we're used to putting like R5 for remainder of 5 or whatever, but that's really not the technical right way to do it. Hold on, put my phone down. My pen's not working for me. Hold on. All right. So instead, the proper way to do it is to take the remainder and write it in a fraction with whatever you were dividing with, right there. So the answer is 5 and 5/6. Now, if the question says that you can't have mixed numbers, then you want to go ahead and shrink it up the best that you can, but don't take it this far. So like if I had, let's say, 20 over 18. So it's still a big one on top. I would treat it just like I will if it's the small ones on top, where you look to see what can they both be divided by. Like both of these could be divided by 2. And you always use the same number on top and bottom when you do your division. So that gives me 10 over 9. And 9 and 10 don't have anything else in common with each other, so that would be the reduced fraction for that one. So here, if it's big over small, you're going to do the long division with the big part on this inside and the small part on the outside. If it's small over big, then you want to find out what both numbers can be divided by. It has to be the same number on top and bottom that you divide by. So when you look at 12 and 21, they both can be divided by 3. That's something that they have in common. And so then this reduces down to 4 over 7. And that is the smallest version of that fraction. Sometimes you have ones that are, maybe have something like 12 over 20. Well, these both can be divided by 2 for sure because they're even, but it's not the biggest thing that can work. So we need to try and find the biggest thing that works for both of these. In this case, it's 4. So then you would end up having 3 over 5 as the simplified version. So that's how you simplify fractions. So the next thing we're going to look at here is how do we add and subtract fractions. And there's a phrase that I want you to be familiar with, like super familiar with, because it's going to help you in all levels of math. When I come across a truth that is extremely helpful to me, I hold on to it. And the deal is this. For addition or subtraction, you can add or subtract what's alike, or what they have in common. Add or subtract what's alike. And what's alike stays alike in the answer. So what they have in common stays that way in the answer. Now, you may not have heard that phrase quite like that before, but you've done it before, because back in grade school when you added 325 plus 14, you knew that to stack them up to add them, you would not stack them up this way, because we knew that the 5 and the 4 had to be lined up, because what they had alike was that they were the same place value. They were the ones place of each of those numbers. So we learned that this would be the proper way to stack them up to add, because we would have alike place values lined up for each of these. So the ones places would be with the ones places, and the tens places with the tens places, and so forth. And then even when you gave your answer, because I said we add or subtract what's alike, but I also said what's alike stays alike in the answer. So if you're going to add ones places here, you wouldn't write the answer over here in the hundreds place. If you're going to add ones places together, then the answer is going to stay in the ones place. If you're going to add tens places together, that answer stays here in the tens place, and so forth. So that's what we mean by it stays alike even in the answer. And then if you move on to another type of math, the same thing happens. We can't add 3 feet plus 17 inches because their labels are not alike. So we would have to change one of them, like we could change the 17 inches into feet, or we could change the 3 feet into inches, and I chose to do that. 3 feet is the same as 36 inches. So now that they have the same label, they're alike, we can add or subtract what's alike. So we're going to add these, and what's alike stays alike in the answer. There it is. It's 53 inches. Even into algebra, there's a thing called combining like terms, and that's adding and subtracting what's alike. And the letters are what have to be alike. The letters and their exponents have to be alike, so this 5y is not like the other two. So we can add these two because they're alike, and what is alike about them stays alike in the answer. So those two combine to become 7x, and then the 5y, we can't do anything with it, so we would write it like that. So then that brings us to the fractions then. We can add or subtract what's alike, and in fractions, when it comes to addition, what's alike has to be the denominator. Somebody told me, think of Notre Dame, like that, numerator, denominator. I always thought of D for down, but anyway, we need the bottoms to be alike. We call them least common denominators, is what that's called. And as long as the bottoms are alike, then we can add. And remember I said, you add or subtract what's alike, and what's alike stays alike in the answer. So that reminds you that you need to also have that same number in the answer. In fact, this now becomes 5/7. So in our study box up here, what we want to put in here is that we need, you can either put LCD for least common denominator, or you can just put the word common or the word alike to represent. That has to come first. And then, as you saw in this instance here, we only added the top digits. We did not add the bottom digits. So that's the major thing we have to consider here, is that we only add or subtract just the tops. And then in our answer, if we can, we will simplify it, in the method that I showed you a moment ago. If you need to, that's what you'll do. So it's 3 steps to add or subtract. You need to get common denominators, add or subtract the tops, and then simplify. So here's a problem where we don't have the common denominator. And so what we want to do is we want to ask ourselves, what would the common denominator be? Well, one way to find a common denominator, there's lots of ways to do this, okay? But we could list the multiples of 5, like 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5. We could make a list of the largest one. And then we could do the same thing with the 4. We could do 4 times 1, 4 times 2, times 3, times 4, times 5, times 6. And what we're looking for is when do they end up having the same answer? And right here it is. 20 is a number that 4 and 5 have in common with each other. So we want to change this problem over to having denominators of 20. So then the question becomes, how does 5 become 20? What happened to it? Well, it was times 4. And so that's how we know what to do with the top. We're going to change the top the same way. If 5 times 4 made 20, then 3 times 4 will give us the other number that we needed on top here. Then we ask the question, how did 4 become 20? Well, it's 4 times 5, and that tells us what to do at the top then. So 1 times 5 is 5, so the top part becomes 5. So 1/4 is the same as 5/20, and 3/5 is the same as 12/20. So now that we have the like denominators, we can add or subtract them because they're alike, and what's alike stays alike in the answer. So we know it's going to have a 20 on the bottom. And so 12 and 5 is 17. So the answer is 17/20. Now, the next thing we're going to go to is how do we multiply? And multiplication is probably the most common thing we do throughout this course, or any course really. But remember, I said here, alike never matters for multiplication and division. So alike only matters for addition and subtraction. If you're ever wondering, do I need common denominators? That's basically you're saying, do I need denominators that are alike? Well, alike never matters for multiplication and division. We add or subtract what's alike, and what's alike stays alike in the answer. Alike never matters for multiplication and division. So getting common denominators is not what we do for multiplication and division. They actually need something else. They need to have fraction form. Everything only in fractions. No mixed numbers, no whole numbers. So we're going to put fractions only here, and it's going to be both for multiplication and division. So we want everything in fractions only. So down here, I'll show you how to do that. Okay. For multiplication, alike never matters. We need fraction form for everything. So if you have a whole number, let's say you have a 6 times 3 1/4, okay? Well, since fractions are division and we want to turn 6 into a fraction, but we don't want to change its value, we will divide by something that doesn't change it. 6 divided by something still gives you 6. 6 divided by 1. So that's why we say if you put any number over 1, it still means the same thing. 6 divided by 1. Now, for this part, for this mixed number, to turn it only into fractions, no whole numbers, we would go around the outside like this. And we multiply here, and we add here. So it's going to be 4 times 3 plus 1. So this problem then becomes 6 over 1 times 13 over 4. 4 times 3 is 12, plus 1 is 13. So now that we have it in this state, we've gotten it in fraction-only form. So the next step, and this is important because you probably were not taught this before. I've noticed that most elementary, middle school teachers and so forth go ahead and let you multiply and then shrink it up or simplify it in the end, which is not helpful to you when it comes to learning other skills later. So it's very important that you learn how to simplify. That's my lovely dog. Charlie, shh. So simplifying works like this. You look at both of the numbers on the top and the numbers on the bottom, and you ask, do any of them have anything in common that I can divide with? And sure enough, both 6 and 4 can be divided by 2. They have 2 in common. So if you divide by 2, this becomes 3. And if you divide by 2 here, it becomes 2. Hang on. I gotta get the dog. Okay. So the last step then, so that we remember what to do, is we multiply straight across the top and straight across the bottom. Okay, we do not cross multiply. And the reason I put both of these here is to remind myself we do not cross multiply That's a whole different situation, by the way. But also, notice with addition and subtraction, we only did the top digits. And I always had trouble remembering when do I just do the top digits and when do I do both the top and the bottom. And so this shows me that I'm doing both the top and the bottom. So now that means I'm going to go 3 times 13, which is 39, and 1 times 2. And there's my answer. Usually that's how they want it, even though the top number is bigger. They usually want it left that way. If it does tell you in the blank that you can use mixed numbers, then you would go ahead and follow our rules from above on how to simplify this, where we would put it in the division box. And 2 goes into 3 one time. And we would subtract, bring down the next number. 2 goes into 19 9 times. And when we subtract, so we get 19 and a half is what would be our answer, because it's this 1 over the 2 and the answer. All right, so let's do another one. Okay, so our rules were, let's go back and look at them. Make sure everything's in fraction only form. Simplify it before we multiply it. And then multiply straight across the top, straight across the bottom. So here we go. So we're going to get everything in fraction form. And that one's done just by putting that over 1. Now we're going to simplify. On the top and the bottom, I noticed that the 7 and the 21 can both be divided by 7. That's what they have in common with each other. So if I do that, 7 divided by 7 gives me 1, and 21 divided by 7 gives me 3. All right, so there's nothing else in common on top and bottom, so now I'm going to multiply straight across the top. So 10 times 1, and straight across the bottom, 3 times 1. And there you have it. So here's another one. Got to make sure everything's in fraction only form. So you're going to go around the outside like this. You're going to multiply, then you're going to add. So it's going to be 5 times 3 plus 3. So we get 18 and then over 5. So the bottom number stays the same. Now that we have everything in fraction form, we're going to start simplifying. I noticed that both of these can be divided by 5. If you divide by 5 here, so you always have to use the same number to divide with. Something not side by side, but top and bottom. Anything on top with anything on the bottom. So when you do that, that becomes 1, and that one becomes 1. These two have a 9 in common, so if you pull a 9 out of here, you get 1, and a 9 out of here, you get 2. So now if you multiply across the top, it's 2 times 1 and 1 times 1, which gives us a 2. Now that's so much better than if you had multiplied first. This would be, let's see, 90 over 45. And that might have been easy for you to reduce, but sometimes the numbers are crazy. So doing it this way before you multiply makes it so much easier. Okay, lastly, we're going to talk about division. And division can't be done the way it is. We do know that we have to have fraction form. I told you that before. It does not have to have common denominators because a like never matters for multiplication and division. But the deal is you can't do the division. It just doesn't work. So what we're going to do, though, is we can turn it into multiplication. So it takes 2 steps to turn it into multiplication. The first step is you're going to change the division sign to multiplication. And then if you've ever heard that word, do the reciprocal, I prefer to say flip the second. Reciprocal means to flip, like a reciprocating saw flips back and forth, that kind of thing. So we're going to flip the second number, so that reminds us which one we're flipping. If you do these steps, if you turn it into fractions only, and then you do these 2 steps, you now have a multiplication problem. So now you can just come over here and start following the rules in this box next door. All right, so let's look at it. We want to make sure we have fraction-only form. So we're going to put that over 1. We're going to come around the outside of this guy. So now we have 8 over 1 divided by 4 over 3, because 3 times 1 plus 1 gave us the 4. And now we need to change the division sign, and we need to flip the second fraction. So we're going to have 8 over 1 times 3 over 4. So now we're ready. It's a multiplication problem now. Now we can do that reducing like we did in the multiplication. We are not to do that until after it's completely changed over. So now 4 can be pulled out of both of these. So that gives me a 2 here and a 1 there. I don't see anything on top and bottom that have anything in common. So now it's 2 times 3 over 1 times 1. So the answer is 6. Let's do it again. Now this one already has everything in fraction form. So we're just going to need to change this to multiplication, and we need to flip this fraction. So we have 16 over 25 times 35 over 24. And we want to simplify. Look on top and bottom to see if there's anything in common anywhere. And it turns out I can see that 25 and 35 both can be divided by 5. So if you do that, this is what your answers are. And then 16 and 24 both can be divided by 8. Yes, they can be divided by 2 and 4, but you want to get rid of as much as possible. If you didn't see that it was 8, you could have done 2 and called this 8 and this 12, but then you need to look at it again. Oh, 8 and 12 still have something in common. They both can be divided by 4. So you can do it in more than one step if you need to. But now we have 2 times 7 on top and 5 times 3 on the bottom. And there you have it. So there's your study box for how to remember all the things having to do with your fractions. How to add, subtract, multiply, divide, and simplify. If you draw this like 20 times on your page, you'll memorize it and you'll probably know it for the rest of your life. I just have met so many people that years and years later they still can do their fractions. And this doesn't have to be drawn any bigger than the size of a business card. So hopefully that gives you some help.